We're going to talk about the difference of scalars versus vectors, and then in a few minutes we're going to talk about mass versus weight. A scalar only has a magnitude. It's just a number of what was counted. The direction and the location is not important. So for example, a 2 kilogram brick is the same on a table, in the ocean, or on Venus. Regardless of where the brick is, the mass is the amount of material inside the brick. The mass does not magically change. It's still a brick that has a mass of 2 kilograms. Vectors have a magnitude and a direction. That means that the vector has a size and it looks different. For example, in this situation, when the person is walking towards the cashier, it's going to look very different than this situation when the person is walking away from the cashier. Although they might have the same speed, they have a different direction. Therefore, the direction is important. Location can also be important. The force of gravity on Earth is greater than the force of gravity on the Moon. So this can be seen by astronauts jumping. An astronaut on Earth is pulled to the ground much faster, if you think about those old videos that you've seen, than an astronaut on the Moon, which are very slow moving. All right, get ready for your mind to be blown. Mass and weight are not the same thing. They tend to be used interchangeably, but this is not correct. As I noted before, mass is a measure of the quantity of material that is contained. So if we look at our brick, there's only 2 kilograms of material in the brick. That does not magically change. The brick has mass. We've looked at that before, whether it be on a table, in the ocean, or on another planet, it is still exactly the same brick. It is a scalar. Mass is a scalar. Weight is a force, which is a vector. Weight is the measure of how the mass moves towards an object. The object being the Earth, or the Moon, or Venus, or Tatooine. Depending on where you are, the movement will change. One of the many benefits of the metric system, and there are several, is that there is a clear distinction between mass and weight. Mass is measured in grams, and weight is measured in newtons. The brick has a mass of 2 kilograms and the weight of 19.6 newtons. Notice when I wrote down the weight, I indicated what direction it was going. I said it was down because, as I said before, in vectors, direction is important. But in the Imperial system, which is a far inferior system, the difference between mass and weight is often not clear. For example, if I am 250 pounds on Earth, this is considered to be my weight, but only 41.7 pounds on the Moon. Looking at this, we have a change of weight based on a change of location. Therefore, weight must be a vector. Since mass is a scalar and weight is a vector, they are not the same thing. Mass and weight are related. by the equation weight is equal to mass times gravity. But as said before, weight is not the same thing as mass. Actually, mass in the imperial system is measured in slugs. But since that is rarely used, it is a dead unit, like Latin is a dead language. It exists, but it's rarely used. Finally, as said before, I find the imperial system to be an inferior system. So as soon as I see something in pounds, I change it into kilograms by dividing by 2.2. Because I want a clear distinction between mass and weight. For example, if I'm given 220 pounds, I'm going to divide that by 2.2, assuming I'm on Earth. Because every planet, every moon is going to have a different divisor. But we use 2.2 for Earth. So that's going to equal 100 kilograms. And a clear weight or force of 220 pounds. Another example is 3,000 pounds becomes 1,363.6 kilograms. Remember, the force is divided by 2.2 to give you a clear distinction between force or weight and mass in kilograms.